Hello and welcome back to the next chapter of this microeconomics course. In this video, I'll be using the production possibilities frontier to help explain and illustrate opportunity costs. Just be careful, the concept of opportunity costs is a lot more challenging than most students initially think, and it's one of the most important principles in economics. So what do we already know about the Ppf? We know that all the production combinations on the Ppf, or on the curve, are production efficient, meaning that they represent production combinations where there is full employment, or no wastage of any productive resources such as labor, land, or machinery, which are used in the production of power lines or wheat within a given time period of a year. There are many production efficient combinations on the Ppf. In fact, every infinite point on the Ppf curve is production efficient, not just the ones highlighted by points A to F. So if all production combinations of wheat and power lines on the Ppf are production efficient, which combination is the best combination? Please note, we don't consider points within the Ppf when trying to find the most preferred combination. The reason why we don't consider any production combinations within the Ppf is because those combinations are not production efficient. Or stated in another way, any production combination within the Ppf curve is automatically not a preferred combination because every point on the Ppf represents a production combination with at least more of one good, which is a combination that is possible by employing any idle productive resources. For any point within the Ppf, the economy does not have to reallocate any productive resources away from producing one good in order to produce more of the other good. This is why any point within the Ppf cannot possibly represent a combination where there is full employment, and why we typically ignore any of these points. When an economy decides to change what it produces at full employment, it has to make sure that the change is worthwhile. For example, let's assume our economy is producing at point B in figure A. This point represents the production of 1 ton of wheat and 14 kilometers of power lines per year. Let's now assume the economy wants to actually produce at point D because too little wheat was being produced or grown for the population to survive. And so point D represents the production of 3 tons of wheat and 9 kilometers of power lines each year. Once productive resources are eventually shifted or reallocated to the production of more wheat, now at 3 tons per year, 2 more tons of wheat are produced per year compared to point B. But while more wheat is now being grown, the economy has had to give up or expense the production of 5 kilometers of power lines per year. Because all productive resources were employed, the economy had to shift some labor and land away from producing power lines in order to produce more wheat. Shifting these productive resources away from power line production obviously results in the economy experiencing a drop in the production of power lines, as illustrated by the red arrow. Let's quickly look at points B and D and more formally calculate the amount that has to be given up when moving from production point B to point D. Looking at the x-axis, we can see that the economy has increased its production of wheat from 1 ton to 3 tons per year. This is therefore an increase of 2 tons of wheat per year. Looking at the y-axis, we can see that the economy now produces 9 kilometers of power lines compared to point B, where it was producing 14 kilometers, and therefore is now producing 5 kilometers of power lines less per year. The 5 kilometers of power lines that had to be given up in order to produce the extra 2 tons of wheat is known as the opportunity cost of producing the extra wheat. The opportunity is to produce an additional 2 tons of wheat, while the cost is 5 kilometers of power lines that have to be given up. Hence the name opportunity cost. When we refer to trade-offs, we mean opportunity costs, which represent what could have been produced. Always make sure you state your opportunity costs correctly. In this example, the correct way of defining the opportunity cost of moving from point B to point D would be as follows. The opportunity cost of producing an additional 2 tons of wheat per year is 5 kilometers of power lines per year when the economy is producing at point B. In order to not get confused, when moving along the ppf from one point to another, always make sure you know what is being given up and what is being gained. Now you try calculate the opportunity cost from point D to C. Be careful. Know what good is being given up in order to produce more of the other good. And opportunity costs can be calculated moving down or up along the ppf. You should find that the opportunity cost of producing 3 more kilometers of power lines is 1 ton of wheat when moving from point D to point C. So far, we've covered a number of relatively simple yet fundamental concepts using our basic two-good economy. But before going on to the next topic, there is one more concept we need to discuss, and it relates to why the ppf is not a straight line. In fact, all the concepts we have covered so far could have been discussed using a straight line ppf. Have a look at the grey arrows appearing on the graph. The length of each of the grey arrows represents a 1 ton increase in the production of wheat, and hence why they're all of the same length. But what happens when we analyze the amount of kilometers of power lines that have to be given up each time we increase the production of wheat by an additional ton? Or stated more correctly, what is the opportunity cost associated with each 1 ton increase in the production of wheat? The red arrows appearing on the graph represent the associated fall in power line production for each 1 ton increase in wheat. Notice how each red arrow is not the same length, or to be more precise, notice how the opportunity costs are not equal in value for each equal increase in wheat production. So the reason why the ppf is not a straight line or constant line is because opportunity costs are not constant. And the reason why opportunity costs are not constant is because productive resources, like land and labor, are not all equally productive. If we assume that in our simple two-good economy that individuals act in a rational manner, then we can assume that productive resources are always allocated to the activity in which they are relatively more efficient. This is actually quite a realistic assumption. If we think about agriculture in the real world, farming generally takes place on more fertile land. So when resources are shifted between activities, in our case either the production of wheat or power lines, the shift or allocation of these resources is done in the most practically efficient manner. This assumption is called the law of increasing opportunity costs, which states that an economy with limited resources will face increasing opportunity costs for every increase in production of a single good. We saw this in the increasing red arrows in figure A. To better illustrate this fundamental principle, let's go through how it applies to our example. To keep things simple, let's only consider labor, although the principles still apply to other productive resources. Our economy produces either power lines or wheat. In order to produce these goods in each industry, it requires labor, amongst other things. When our economy in figure A wants to produce more wheat, it needs to shift some of its productive resources away from producing power lines to growing wheat. But it wouldn't take its most productive power line producing resources first. In fact, it would take its relatively least productive power line producing resources first, which is the same as saying that the most efficient wheat farmer currently producing power lines will be shifted towards producing wheat first. This would lower the opportunity cost associated with the increase in wheat production, because the labor that was given up to produce the extra wheat wasn't actually as productive as any of the other resources currently producing power lines. By taking the most efficient farmer, or in other words, the least efficient power line worker, away from producing power lines, what the economy is doing is minimizing the fall in power line production. So as the economy shifts more and more labor towards the production of wheat, the labor which it is shifting is more and more efficient at producing power lines. This is why for each extra ton of wheat produced, the opportunity cost, in terms of power lines given up, increases. Take your time to fully grasp this concept. Once you get it, you'll be okay, and you'll be able to apply it to concepts we'll be covering in future lectures.